evaluating liquid and solids. So we can use this approximate method. You see this on the steam table. We have this approximate method for looking at the properties of liquids and solids. So this is for liquids and solids. And we can, anyway, it's fairly easy to look at this. But if you go to the table, like you go to table A5 and your values aren't there, A5 is a table for compressed liquids. So if you go to table A5 and the values you have are not there, we can approximate them. We can approximate specific volume as the specific volume, the saturated liquid specific volume, or VF, at the temperature T that we have. Instead of specific volume being a function of temperature and pressure, we just do it as a function of temperature. And here these should have the little F's as well. So we would, specific internal energy as a function of temperature and pressure is approximately equal to the saturated liquid specific internal energy of a specific temperature. So compressed liquids on table A5E, we'll show you an example here, but compressed liquids water show V and U change very little with the pressure at a fixed temperature. For liquids, V and U may be evaluated at the saturated liquid states, VF and UF, corresponding to the temperature of the given state. That's what we've just talked about there. But here's an example of that. So if we look at table A5E, and we have a temperature of 150 degrees Fahrenheit, and then this is the saturated pressure, 3.722 lbf inches squared at the given 150 degrees Fahrenheit. And then you can see, so you pause this right now video and go look at table A5E and see these values for 150 degrees Fahrenheit. These are your values. So the saturated liquid, saturated pressure, and then the fluid, the specific volume, specific internal energy, and specific enthalpy at saturated liquid. So we have these values in the first column here. And those actually I got from table A2E. And then if we look up on table 5E, A5E here and here, we can pull off the values for a pressure of 500 lbf inches squared, and then a pressure of 4,000 lbf inches squared. And so this is what we get here. These just come right off of table A5E, and these come right off of A5E. So you can see that what they're telling you to use is use this value, use this value as an approximation for these values instead of this and instead of this. Because you can see that the difference in these numbers is really small, even though my pressure, so I'm holding my temperature constant at 150 degrees Fahrenheit, and my pressure goes from 3.7 to 500 to 4,000, and my specific volume changes very little. It's 1.16% decrease from the smallest to the largest of these two values. And then likewise, we want to use this one for internal energy, that for internal energy, and we can see that these are the other two values that we have, and the biggest difference between these is this. It's 1.1 or 1.85%, so it's a very small number, decrease between what we're going to use and the smallest one, the biggest difference there. And then likewise, in enthalpy, we can use this for enthalpy here, and it's approximating these two values. And you can see even for the big change in pressure, this one has the biggest change, but it's still 8%. It's still within a range of errors that's acceptable to us. And so you can use the saturated liquid values for approximating our values for the specific volume, specific internal energy, and specific enthalpy. So this example just shows you that it's not a very big difference.